So the next part here with dealing with numbers and accuracy is exact or approximate. And so most of the time we're approximating. We don't get exact, but the more we can approximate to more decimal places, the more accurate it is, the closer it is to exact. And so I'm just going to talk through a couple of these examples. But basically, if you think about our rounding, for instance, let's say we have a number that's 68.5. Okay, if we're rounding to the whole number or to 2 sig figs, that's going to round up to 70. Okay, and so what they're talking about with these ranges is if Jane's weight is 68, determine the upper lower bounds. Well, if you're rounding to the nearest kilogram, then 68 has to be less than 68.5, because if it was 68.5, you'd round that up to 69. And it has to be greater than or equal to 67.5, because 67.5 is the first place that you would round up to 68. And so they say plus or minus because they're talking about accuracy, but if you're thinking about it as an interval, you're always rounding up the 0.5. I think it's easier to see on the second one. 0.5, that rounds up to 155. Like if we're saying it's 155, and anything less than 155.5, because 155.5 would round up to 156. Mostly you need to be able to identify which is the exact and which is the approximate. So we're going to go down here to these problems. There's a formula because they're going to ask you to estimate error in rounding. There's always some error when you're rounding. And so it says find the percentage error in using 3.14 instead of pi. So 3.14 is an approximation. So we have this nice formula. These are big absolute value signs. That means there's no positive or negative. And so on my calculator, I have a pi button that I'm going to use. So A is the approximate, E is the exact. So I'm going to subtract those two. Shadow out of there. So I'm going to take pi, or the approximate, 3.14, minus the exact, whatever pi is saved in here. Okay? And then I'm going to divide that by the exact. So I'm going to divide it by pi. And so I get this really small number, negative 5.07. And notice there's this E over here. That's times 10 to the negative 4. I'm kind of teaching you scientific notation here as we go as well. So 5.07, I'm dropping the negative sign because it's absolute value, times 10 to the negative 4th means I move this over 1, 2, 3, 4, and I put in zeros. So the actual difference is 0.000507. And then the formula it says times 100%. Basically that means to get a percent, you move it 2 places over. So this would be 0.0507% off. Okay, the second one, Andrew Waugh announced Mount Everest to be 8840 meters high. After several years of calculations, more recent surveys confirmed the height as 8848. So the more recent surveys are more accurate. It's being implied in this problem. So we always subtract the approximate, which is what he declared, minus what they actually are, the exact amount, and we divide by the exact amount. That's the key, is what are you dividing by? You always want to divide by the exact amount. You do this in business, and it's something called percent change. So again, use your calculator. You always have it. 8840 minus 8848. So he was off by 8. Okay, so we're dividing 8 by 8848. It's pretty good.